if I gave you this problem right off the bat, you told me just a second ago your first inclination would be to cross multiply, okay? And why is your first inclination to cross multiply? Two fractions set equal to each other. That's the only time we can. Is everybody clear on that? We're going to talk about that some more here in just a second, but this is a perfect time when we can cross multiply, okay? If we cross multiply, what we get is this times this. We get 4 times x minus 4 equals this, right? 7 times x plus 3. Well, that's suddenly a whole lot easier problem than what it looked like before, right? There's no fractions. We've done problems like this for a while now. Haven't we? What do we do from here? Distribute, right? We did that. So now what? That's all right. Subtract 4 on both sides? Oh, subtract 4x from both sides. I'm okay with that. Is that the only thing we can do from there? No. Several different things, right? So that's what we have so far. Now what? Would I subtract 21 or would I add 16?
Add 16.
Does it matter? Ooh, at this point it does. We want all our x's on one side and all of our numbers on the other, right? So I should subtract 21, okay? When I subtract 21 from both sides, what do I get? Negative 37 equals 3x. How do I solve for x? Divide both sides by 3. There's someone sitting in this room right now whose first thought when they saw this is, I must have done something wrong because it's not a nice number. Because people always think that. It's the first problem on the worksheet. It's supposed to be a nice number, right? Negative 37 over 3 is not a nice number. So the first thing I need you to do is get over that. We'll be fine. Okay? X equals negative 37 over 3. Okay? Now, there's some weird boxes over here. We need to talk about those weird boxes. Right? The first weird box says restrictions. Now, that's not usually a positive term, right? Usually it's because you've gotten in trouble, now you're on restriction. Or grounded or something like that, right? Well, it's kind of the same way here. It's stuff that can't happen. You did something that you weren't supposed to do and you got restricted, right? There's something that can happen here that something bad will happen if we don't take care of it. Restrictions. Okay? Looking at this problem, I know it's kind of hard to see with my green marker or my pen, whatever, but you guys can see it pretty plainly on your own paper. Can you think of anything that would cause a restriction for this problem? So some of you are thinking, okay, this is a fraction, so that should tell me something, right? Because in a fraction, my denominator can't be 0, right? I know you all thought of that, right? I could tell, right? Well, are either one of my denominators 0 right now? Oh no, so we're good, right? But is there anything that could be x that would make this denominator 0? Negative 3. Negative 3 plus 3 equals what? 0. That's not okay, right? We've had this discussion before. Are we ever allowed to divide by 0? No, only one person can. Who is that? Well, person. Chuck Norris, but he's not in here, right? Okay, so we can't do it. So if we're trying to find restrictions, then is there like a thing that we can say that we could always be able to figure out our restrictions? What would make this denominator 0? Negative 3, right? We said that a second ago. Well, what would make this denominator 0? Positive 4. How did you do that? Some of you can do it in your head, and that's great, but they're not always that easy. So let's get a general idea of what to do so that we know how to find our restrictions. Very, very good. Let's set each denominator equal to 0. So first we have x plus 3 equals 0. Oh my gosh, look what we found. X equals negative 3. And then we set the second denominator equal to 0 if there happens to be two denominators. X equals 4. So here's what's funny about the restrictions. I just found the two values that x cannot be. Okay? Some people are confused by that because it says x equals 4, so x should equal 4, right? Well, x can't equal 4. So we're going to write x can't equal negative 3, and x can't equal 4. For the record, you can write it like this. Either way is fine with me. Okay? So what does this sign mean? Have you ever seen it before, by the way? Good. We've talked about it in here before, right? We're talking about domain. Okay? Ooh, doesn't that help us restrict our domain? If we know what x can't be? Oh, yes it does. Okay? LCD, what does that mean? Least common denominator. We didn't really deal with the denominator in here because of the fact that we cross-multiplied. But if we were dealing with the least common denominator, can you tell me what it would be in this case? I think we talked about this before. When in doubt, when you're trying to figure out the least common denominator, when in doubt, multiply them together. Right? So this least common denominator would be x plus 3 times x minus 4. Got it? Okay. But again, we didn't really deal a whole lot with that. We didn't even talk about it when we were doing the problem, did we? Okay. But again, I know it's coming, so I know I needed to take you there a little bit. Okay? Because look at number 2. Can we cross multiply on this problem? Why not? It's not just two fractions that equal to each other. Excellent. Okay? So how do I want to do this problem? Most people say, well, it's addition of fractions, so I want to find a common denominator, and then I can add them, right? Do you really want to deal with fractions, if at all possible?
Not really.
So what if we could get rid of the denominator? So what we're going to do is we're going to find the least common denominator and use it not to get everything a common denominator, but to get rid of the denominators. Okay? It's like we're a denominator assassin. Yeah, that's exciting. It's really hard to say too. Okay? I had to think about it very carefully. All right? So, looking at these denominators, what do you think our common denominator would be? Remember, it has to be all the factors that each of them have to end up in the least common denominator. So 3x. Is everybody okay with that? So my least common denominator is 3x. I'm going to go ahead and write it over here. Okay? Now again, I told you we're not going to find a common denominator. I mean, for each fraction, we're not going to make it each have a common denominator. We're going to use the least common denominator to get rid of all the denominators. And the only way I can do that is multiplying every term by the least common denominator. You okay so far? Excellent. Okay. What happens here in this first fraction? Oh, the x's cancel out because they're both factors, don't they? And what do we end up with? 3. Oh, that's much nicer. What happens in the second fraction? Ooh, the 3's cancel out, don't they? Okay. And what am I left with? 13x. And then what happens in this last fraction? The x's cancel, and what am I left with? Equals 21. That's a much, much, much nicer problem to have to deal with than that one, isn't it? But guys, they're equivalent. Okay? All right? So, what do I do now? I want to try to solve for x, don't I? Get the x by itself. So probably subtract 3 from both sides. 13x equals 18. How do I solve for x? Divide both sides by 13. X equals 18/13. Are there any restrictions? How do we find restrictions? Huh. I don't know who said it, but I just heard it. So can I say something real fast? I mean, if you say no, I'm going to say it anyways. You said set the denominator equal to 0, right? Somebody said that. Maybe it was you? Okay. Over there? Okay, so one of you guys? Haven't we already done something like that? Haven't we already set the denominator equal to 0 to find something? Well, what were we finding when we set the denominator equal to 0 last time? The vertical asymptotes? Wait, so the vertical asymptotes is where x can't live? Oh, there's an asymptote there. There can't be anything there, can there? So, do you understand why our restrictions are what they are? Where they come from, what they mean, things like that? Does that help a little bit? Okay, so are there any restrictions in this problem? Well, if I set this denominator equal to 0, I get x equals 0. Oh look, there's a restriction. X cannot equal 0. Then I set this denominator equal to 0. 3 equals 0. No it doesn't. Not in this kind of math we're talking about now, right? And then we set the last denominator equal to 0. X equals 0. Oh wait, I already knew that. Done. Oh, you mean so I didn't have to set that last denominator equal to 0 because I'd already done it before? Okay. Do you see the pattern I'm trying to get you to think of? Set all the denominators equal to 0? Okay, you guys are smart enough in your head to realize, oh wait, I already did that, I don't have to do it again. Okay, because it's going to give me exactly the same thing. Okay? Let's just go right for number 5. Right for number 5. There's no crying. Okay? What do you think I had to do first with this denominator? Factor it. That's exactly right. What are the factors of this denominator? X plus 2, x plus 3. Very good. Okay? Wow, that really makes the restrictions a lot easier to see, doesn't it? If I have to set this denominator equal to 0 and that one, that's already there, and that one, that's already there, how many restrictions are we going to end up with in this problem? Very good. 2. Okay? One of them is going to be x plus 2 equals 0. One of them is going to be x plus 3 equals 0. So somebody please tell me what are my 2 restrictions. Excellent. X equals -2, x equals -3. Now that I know my restrictions, what is my least common denominator? It has to be all the factors that are there, right? Yes, say it. X times 2 times x, x plus 2 times x times 3. I don't know what I'm saying. You know what I'm saying, right? How about if I write it down and you'll know for sure what I'm saying? X plus 2 times x plus 3. I have to multiply this. X plus 2 times x plus 3. I have to multiply this. X plus 2 times x plus 3. Is that better? I only said it like 84 times. So someone please tell me what happens with the first fraction in our problem. X plus 2 cancels out, simplifies to 1. X plus 3 simplifies to 1. So it's just 3. After all that mess, it's just 3. Good. Somebody else, please. Tell me what happens with the second fraction in this problem. Excellent. X plus 2 simplify to 1. What am I left with this time? X minus 1 times x plus 3. Now, this crazy kid earlier wanted me to write x plus 2. Guys, are we adding these two things? What are we doing? We're multiplying each term by those things. So whatever's left over, like in this case x plus 3, I'm multiplying it by what's there already. Does that make sense? Okay. And what happens with our last fraction? X plus 3 simplify to 1. Excellent. So here I end up with 7 times x plus 2. Now we start distributing, right? Okay. So this is still a 3. I don't mess with that. Here I get x squared. Here I get 3x. Here I get negative 1x, or negative x, either way. And here I get negative 3. And then here I get 7x plus 14. You okay so far? Okay. What can I do? Combine your like terms, right? Okay. So on this left-hand side, I do have 3 minus 3. Oh, that's so nice. Oh, good, 0. Somebody knows what that means. Excellent. And then I have 3x minus x. So I have x squared plus 2x equals 7x plus 14. What kind of problem has this now become? A quadratic. When we solve quadratics, what do they need to equal? 0. If I subtract 7x from both sides, and I subtract 14 from both sides, I end up with x squared minus 5x minus 14 equals 0. What should we do with that? Now we know we can solve it with the quadratic formula, right? Any quadratic, if it's solvable, can be solved with the quadratic formula, right? But somebody else said factor. Can we factor this one? Do you know what multiplies to be negative 14 and adds to be negative 5? 2 and 7? 2 and negative 7. So can I write x plus 2x minus 7 equals 0? Which one of them equals 0? I don't know either. One of them has to, though, doesn't it? Because I'm multiplying two numbers together and the answer I get is 0. So one of them has to. I don't know which one, so I just think maybe both of them do. So I cover all my bases and say x plus 2 equals 0, x minus 7 equals 0. So x equals negative 2, x equals positive 7. Done? Why not? No. When we're asked to solve, what are we looking for? The values of x. Did we find the values of x? So are we done? Oh, we have to check them. What do you mean we have to check them? So you want to take the whole time to put them back in the equation? Yeah, I don't either, right? But is there something I could do to help me out? I don't think this is a good answer. I don't think it's a good answer. I think it's not an answer for this particular problem. You know why I think it's not an answer? Because it's a restriction. We already figured out that x is not allowed to equal negative 2. Why is x not allowed to equal negative 2? It will make the denominator equal to 0. Exactly. Okay? This cannot work. 7? X equals 7. How hard would that be to check? Put in your calculator. Not hard at all. Guess what? It works. That's my answer. X equals 7. We'll get there in just a second. Oh, good question. We actually already did the least common denominator. We just didn't write it in the box, right? What was the least common denominator? Very good. Yeah, yeah. That's what we multiplied each term by to get rid of the denominator. So that's my least common denominator. Okay? So you have two problems for homework tonight, number 3 and number 4. Okay? We need to talk about something else, though. The worksheet's called Plug and Solve. Okay? Worksheet's called Plug and Solve. It says, shown as a graph of this equation. That's a rational equation, isn't it? You can tell also in the graph because it looks like it has 2 parts. Okay? Set up and solve an equation to locate the vertical asymptotes of this function. How do we find vertical asymptotes? Set the denominator equal to 0. Yeah, that's kind of what we just did with the restrictions, right? So 2x minus 3 equals 0. How do I solve that? Add 3 to both sides. So 2x equals 3. Divide both sides by 2. X equals 3 halves. Is there a better number for this problem than 3 halves? 1.5 is probably a little bit better because we're going to need to find it on a graph. Okay? Now, is 3 halves a wrong answer? No, you know very well as I do that that's not a wrong answer. But since we are trying to find it on a graph, we probably want to have the decimal so we can find it a little easier. Okay? So I'm going to go ahead and draw that in. That's a vertical asymptote. Okay? Point A, everybody point to point A with your finger. Actually point at it. Everyone's touching point A on their paper. Yes? Okay? Point A has an x-coordinate of -3. Evaluate the function to find the point's y-coordinate. There's about 42 different ways we can do this. What do you want to do?
The easiest one?
The easiest for you or the easiest for me?
The easiest that everybody will understand.
Can I say control divide so I get my little pretty fraction thing? 4x plus 1 over 2x minus 3. Oh good, those two look alike, don't they? The one on my paper and the one on my calculator. How am I going to find the y value when I know x is -3?
Go to your table.
Oh, go to my table. Good call. Look for x is -3. -1.222. We'll go to the 1,000th decimal place. Everybody get that? Is there another way to figure it out? That you know of that we've done before? If you know x, how do you find y? Yeah, look. What's 4 times -3? -12 plus 1? -11. What's 2 times -3? -6 minus 3? How about if I learn to read a table? Are you guys okay with that? Could you tell I thought something was wrong? Isn't something wrong? What's 11? -11 divided by -9 going to be? Something positive, right? So I read my table wrong. What's wrong with this? Yeah, there's not a negative. It's just supposed to be a positive 1.22. Sorry about that. Guess what 11 divided by 9 equals? 1.22. 2. Okay? So there's 2 ways that you can do that part of the problem. Okay? Point B has a y-coordinate of 5.5. Everybody touch point B. Everybody. That means everyone is touching point B right now. Good. Set up and solve an equation to find its x coordinate. How are we going to do that? So 5.5 equals 4x plus 1 over 2x minus 3. How do I solve that? Let me make it a little easier. How do I solve that? Cross multiply, right? Okay. So I get 4x plus 1. I'm clearly not going to have enough room in this place if you need extra paper. Or I copied a place for you to work on the back of this. It is a blank page. That was just a little joke. Okay. Equals 5.5 times 2x minus 3. Okay. I'm going to go ahead and copy that on the back of this page so I can continue doing the math. 4x minus 1 plus 1 plus 1 equals 5.5 times 2x minus 3. Okay, how do we solve this? We want to distribute on the right hand side. So what's 5.5 times 2? Guys, what's 5 times 2? 10, right? Okay, so we know it's somewhere around there. It's 11x. What's 5.5 times 3? If you can't do that in your head for right now, that's okay. We're still working on that. But you also have a calculadora in front of you, which is, I think, Spanish for calculator. Is that correct? You guys are better at Spanish than me. So 5.5 times 3. So let's subtract 4x from both sides and get 7x. Can I do two steps at once? Are you okay with that? So can I add 17.5 to both sides at the same time? I mean 16.5. I'm already trying to tell you the answer. Sorry. So when I divide both sides by 7, 17.5, whoops, you can't even see that, divided by 7, 2.5. X equals 2.5. Wait, what does that mean? That's the x coordinate when? Very good. When y is 5.5, x is 2.5. Okay? Now, what is the interval over which our fraction, our rational equation function that we've been dealing with is greater than 5.5? When our y value is greater than 5.5. Well, isn't our y value of point B 5.5? So I'm really talking about like some sort of horizontal line right there, right? Because I want to know when it's greater than 5.5. Well, look at the graph. Some people can do this without the graph. I struggle with it, just to be honest with you. I want to look at the graph and see where is it greater than this line. Isn't it that part right there? So what x values will give me something greater than a 5.5 for my y value? It's going to be everything less than whatever the x value of point B is. Oh my gosh, I just found that. So it's going to be everything less than or equal to 2.5. Is that all I have to take into account? So everything less than, everything to the left-hand side of this? Or what happens right here? That's the asymptote, isn't it? Is it ever going to get to the asymptote? No. So I also have to have this, my asymptote's at 1.5, right? Why did I put that sign?
Because
It can't ever get there, can it? Okay? So it asks you two different things. Show symbolically and on a number line. Well, that's symbolic. Number line I need a 1.5, and I need a 2.5. Does it ever get to 1.5?
No.
Then please remember that I have an open circle on 1.5. Does it ever get to 2.5?
Yes.
Then please remember I have,
Okay.
perfect, a closed circle on 2.5. And where are the values true? Everything in between or everything outside? Yeah, everything in between. Because it's greater than 2.5 and less than or equal to 2.5. I think I said that wrong. Everything greater than 1.5 and everything less than or equal to 2.5. So there's my answer on a number, symbolically and on a number line. Okay? Over what interval is this rational function less than or equal to 5.5? Well, isn't it this part down here? Zhunk, zhunk. Yes? It's that part right there and this part right over here, isn't it? So, instead of being in between these two values, what is it going to be? Outside those two values, isn't it? Okay? So, this time my answer is going to look like everything less than 1.5. It's still less than because it still can't get to that asymptote, right? But it's all this part over here. And everything greater than 2.5. Wait, is that right? Can it ever get to 2.5? Yes. So yes, you're right. It absolutely should be greater than or equal to 2.5. So how do I show that on the number line? Here's 1.5. Here's 2.5. Does it ever get to 1.5? So an open circle. And it's everything less than that. So it's that way. Right? And then it's everything greater than or equal to 2.5. So I do have a colored in circle. And my arrow is facing to the right. Questions? 6, 7, 8, 9, 3, and 4 is what I need you to do for tomorrow. Okay? Are there any questions? That was pretty good timing. I hope you guys have a great day. Peace.